well-known science experiment to mix cornstarch with water and then investigate all of the crazy things you can do with it. But before we have a look at why it's so strange, let's actually do that experiment because, well, otherwise it'll be no fun.
So, this is it. Looks just like any ordinary liquid, right? Well, it is. Until you try to hit it with things. Then it becomes solid. Very solid. If you try to move it around quickly, it's very difficult. Liquid. Solid. Liquid. Solid. You get the idea. Anyway, I had way too much fun playing with this stuff, and you should absolutely go and try it. Just don't drink it. It tastes disgusting.
So, now we know what happens. Why does it do that? I mean, if you try and slam your hand into a bowl of water, that works fine. So what's different? Cornstarch in water is an example of a non-Newtonian fluid. A Newtonian fluid is one where the viscosity depends only on its temperature. Picture a flowing liquid as a load of layers stacked on top of each other, moving past each other. For a Newtonian fluid, as long as you don't change the temperature, if you want one layer to slide over another twice as fast, you need to double the force. A non-Newtonian fluid is, surprisingly enough, a fluid that's not Newtonian, which means that if you double the force, you don't double the rate at which the layers slide over each other. Cornstarch and water is part of a group of non-Newtonian fluids that are shear thickening, which means that the more quickly you try to move the particles in the substance over each other, the more viscous the substance becomes. So, if you put your hand slowly into the mixture, it doesn't change its viscosity much. But if you try to push the particles over each other more quickly, for example by slapping your hand against the mixture, the material becomes so viscous that it essentially behaves like a solid and it stops your hand. So, the obvious question is, why is cornstarch non-Newtonian? Well, after a lot of trawling the internet, I've discovered that no one actually knows. Studies have shown that the closer together the particles, the slower the speed at which its viscosity increases, but that's as far as we've got. Which surprised me, since this is a really well-known experiment, so I was expecting that someone would have actually figured out how it works by now. But they haven't, which serves as a reminder that there are questions that even science doesn't know the answer to yet. And that's quite a depressing ending, so instead, look at this cool science! If you want more science, then subscribe! Goodbye! Please just appreciate what a complete mess I've made now.